like in the spirit of reconciliation, the Statistical Society of Australia acknowledges the traditional custodians of country throughout Australia and their connection to land, sea, and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. So it's my great pleasure to have for tonight's seminar of the New South Wales branch of the SSA, Tom Honeyman, who manages the program of activities at the Australian Research Data Common to work towards the recognition of research software as a first-class output of research, and was the primary author of the ARDC's National Agenda for Research Software. Prior to that, Tom completed his PhD in descriptive linguistics, working on just one of the over 800 languages spoken in Papua New Guinea. While Tom spends more time these days talking about software than developing it, he has also worked as a research software engineer in the past and also in the data archives or repository space. Today, it's going to talk about recognizing the value of research software. As I said, it's my great pleasure to have him today. So just before starting, I just remind all of you in order to reduce the noise, to switch off your microphone. And we're happy to take any question at the end of the seminar. So thank you very much, Tom, to be with us tonight. And I'll let you start your talk.
Well, thank you, Clara, for that lovely introduction. And it's actually my great pleasure to be with you here tonight. I think one of the things that I enjoy about my job more than anything else is that I get to meet researchers from really across the spectrum. And it's just so interesting exploring the different ways of working, the different concerns and interests in each area. And I really look forward to your questions at the end because as an explorer of the research world, I do often find that as I traverse the landscape, I find very different ways of thinking about things that have the same label or that are, you assume that you have common knowledge and you find out that things are just a little bit different. So let me start by sharing my screen, and I hope this is going to work. Are the slides showing now?
Yeah.
Okay, terrific. Okay. So I am going to talk about recognizing the value of research software. I'm going to acknowledge that I'm doing this very much from an ARDC perspective. And so, as we walk on this journey, I would like you to be a little open-minded about some of the terminology that I use and try and find that common ground. We've had an acknowledgement of country, but I like to give an acknowledgement of country too. All I would like to do is acknowledge that I'm joining from Gadigal lands in the Eora Nation right now. I always ask people if they would like to acknowledge which lands they're joining from in the chat as well. So I do come from the Australian Research Data Commons, and it's obligatory that I do this slide. What the ARDC is, or what it has as a purpose, is to provide Australian researchers with a competitive advantage through data. And our mission is to accelerate research and innovation by driving excellence in the creation, analysis, and retention of high quality data assets. Now that's a big picture thing. And actually where I kind of slot in at the ARDC is really around the analysis and to some extent the kind of handling of data. We really see research software as a massive enabler of data's value and an enabler of research more generally. We think it's a really powerful output of research. So today we're going to cover very briefly what the research software agenda is, or what the ARDC research software agenda is, because it is a kind of strategy for tackling this bigger, quite big picture issue of recognition of research software as a first-class output of research. And the way that we break that down is in a nice, easy slogan, which is that we want to see, shape, and sustain research software. Now, what that means is what I'm going to dig into. So a little context about the ARDC Research Software Program. So the program, as I said, is in aid of recognition of software as a first-class output of research. So what that means is that software that's produced in a research context has the same or equivalent status as other first-class outputs in the scholarly system. And you can essentially understand first-class outputs to be publications. Publications are what allow you to progress in your career. They are, to some degree, the measure of the output and quality of a researcher's work. And what we would like to see is that when a researcher puts down code, when they express new ideas, methods, and models, when they work to maintain and provide methods and models to researchers for use in research, that they should get recognition in much the same way, that this is actually capturing it's capturing knowledge in a way that's actually uniquely actionable. So it's a wonderful form of output, in my opinion. And so what we did as a sort of first step in our journey to try to realize that very high level vision is produce a national agenda for research software, which is available there at that link. And we validated that with the community last year. And we've had to date, I think it's getting close to 2,000 views on that document, and the active participants in the validation process were about 400 people. And what that agenda does, or actually what we do very often in the ARDC, is we think about actions across a spectrum of possibilities. We are part of the National Collaborative Research Infrastructure Strategy, and we do produce digital research infrastructure. So one of the things that we do is produce infrastructure. And that infrastructure is supposed to make things like first-class output of research possible. We also produce a lot of guidance because we want to make it easier for people to use that infrastructure. The most ideal infrastructure is both easy to use and basically invisible. So the third thing is we sometimes catalyze or support communities because really we see this as the heart of any change in practice, and particularly in research practice. And then finally, we actually have teams dedicated to monitoring and acting on policy. And what I would generally call advocacy includes specific interventions or incentives being rolled into the system as well to try to help change. So that's still sounding very abstract, and I'm going to get closer and closer to some concrete actions as we go. In that agenda, we identified that there were three big challenges, big cultural challenges that we needed to tackle if we were going to see research software recognized as a first-class output of research. The first big challenge is what I would generally call the shift to more transparent practices. You might know this as open science, but I prefer to frame it this way because I think there is a general trend to research being done in a way where the various elements that make up a standard research project are increasingly being called on to be done in a more transparent fashion, whether that's open access publishing, or whether that's making your code available or your data available, or documenting protocols, or in some disciplines, there's been concern with pre-registration and other things as well. But this shift is the bigger cultural challenge. The second big cultural challenge is really quite specific to software, and that's enabling broad impact through quality software. We know that software gets generated in various ways within research, And so what steps do we need to take to make sure that that effort is fit for purpose, and getting the maximum impact that it can? The third one is the lack of support for research software infrastructure in itself. So we see a big gap between what we would call development of prototype tools, which is just laying down proof of concept or new bits of software, which do typically happen within a standard funding window. So a funded project might enable the creation of a new software idea, a new software method, or a new software model. But then as that moves on to being taken up by people, or if it is taken up by people, there aren't that many ways within the current system for that software to be maintained. It basically introduces a debt on the person, depending on the software, of course. But so we call that big challenge the lack of support for research software infrastructure, which is this idea that there is a type of research software which is actually something that people depend upon, like roads and utilities and so on. It's a form of infrastructure within research. So we basically have three corresponding goals for those challenges, which I've flagged before. We want to see research software, shape research software, and sustain research software. And to express those as actions, we need to take action to make software more visible. We need to take action to make new research software appropriately shaped for broader suitable reuse. And we need to take action to make existing research software, particularly the ones that are valued by research communities, more easily maintained. So now I'm starting to get even more concrete. Let's talk about what it means to make software visible, to address that shift to more transparent practices. What we say is that we see research software when it is shared, published, or otherwise made available on creation, cited or identified in reuse, and captured in data provenance or workflows. So that's the third one in particular is a kind of technical metadata concern. So from what I've observed about the stats community, there are people making their code available. Not everybody is making their code available. And I'm going to go out on a limb here and say, I think if they are making it publicly available, they're probably publishing it on GitHub and or submitting it to CRAN or something similar. There might be other package managers that you prefer. You might not be working in R, you might be working in Python. That might dictate where it goes. You might not like GitHub because it's owned by Microsoft. You might be using another public code repository, or you might just be developing it on your machine and not actually publishing it on GitHub. So I'm really only going to critique those two options that are put up on the screen and recognize that there are other mini branching possibilities here. So GitHub is a social code development platform. Unfortunately, the convention in the world of Git is to refer to the bundle as a repository. And this makes my job very hard, basically, because there is another sense of the word repository. And that's the term that's used particularly in the data world. And what it is a trusted place that preserves a record of work done. And so when we put our things up on GitHub, that is a fantastic place to bring people into the collaborative development, potentially, or at least live development of a piece of software, but it's not a stable record of that software. It's quite possible for you to delete that software once you put it up there. And it's really up to you how you handle it in terms of flagging the moments within that code where you want to, say, release it to name the mechanism directly. And the other problem with GitHub is it's not very good at metadata. So what we've seen arise in the world of mashing together GitHub with this sort of data repository or archive-minded approach is a kind of bolt-on approach where you put a sidecar file, a metadata file in your repo. I'm not bagging that too much. It's actually, GitHub was never meant to be a data archive in that way. But there are these mechanisms for clarifying citation metadata. So if you've never heard of it before, I really do encourage you to check out citation.cff files. There are point and click tools for assembling the YAML file with the appropriate fields. And what that does is formally captures in metadata the preferred mechanism for citation, and by the by, also separately kind of clarifies who the author is and other important pieces of metadata for publishing software. Code meta and really Zenodo.json is very specifically for people using Zenodo as a generalist repository, are also options for describing software. Their primary use case is not for citation, but rather for description and therefore discovery of the software as well. It's, if you like, another way of drawing more people towards your code. So what we promote at the ARDC is the idea that you can actively develop on GitHub, but you can also deposit your code, and if you're comfortable doing it, you can do it via GitHub Actions to automate it on a release basis. So you deposit those in Zenodo and Figshare or Figshare or other generalist repositories. I think in the future, even your institution's data repository would be appropriate. And that solves the issue of having a stable record of the software. So this is okay. Let me continue. So with CRAN or other package managers or similar, these are excellent for directing a community of users to your software. I'm not suggesting that anyone move away from this, but it actually has a similar problem in that it's not necessarily a stable record, and it's pretty close to it. I'm not going to bag CRAN, although I hear it's a thing. It is also actually not very good at what people in the information sciences would say is decent metadata. But you can kind of augment the metadata capture when you make a submission to CRAN. As much as possible, you should be identifying and using relevant permanent identifiers. So persistent identifiers, sorry, I don't know why I wrote permanent. So ORCIDs, which I hope everybody on the call has got an ORCID and is using it. DOIs, I'm going to explain how you get a DOI for your software in a minute. There are also other identifiers that you can use, for instance, for your institution. It's a great idea to add your grant identifier to your metadata digest if you're okay with that too. But yeah, there's a sort of limit to the number of fields that are captured in a CRAN record. And so if you really want a full metadata record to exist for your software to aid in discovery, it probably has to exist somewhere else. And there's nothing actually wrong with having more than one form of availability for your software, as these can exist for different purposes. So for active use of your software, CRAN is absolutely fine. For building a more stable and transparent world world of research, having those deposit forms of software will actually help over time build a more stable research world as well. So this is a shift in practice, and it's quite possibly for all of you or some of you on the call a fairly odd shift in practice. We do recognize that, and that's why we make guidance available to aid the aid that shift. What we have right now is the AIDC Guide to Making Software Citable that has the absolute minimum steps for publishing your code in this way. Perhaps the easiest at the moment is to just snapshot releases to Zenodo, which is a CERN-backed free generalist repository, which holds a lot of things. In an earlier version of this talk, people were surprised that they could get DOIs for their software. And actually, you can do that for more than software. You can do it for presentations or other things. DOIs are great. And what they do is they, in the background, to some extent, automate the tracking of your research outputs as well. So if you if you deposit your code or deposit releases of your code into Zenodo, it actually gets added to your ORCID listing of outputs as well. So if you're worried about capturing at the end of the year your research outputs, you actually get that listing for free in your ORCID record. So the minimum steps are covered in that guide, and we'll have more specific guides coming. Unfortunately, we're right on the cusp of a website refresh, and so there's all this content that's due that I'd love to be able to link you to, but I just have to put it in brackets and say it's forthcoming at the moment. Other resources that you can draw on are, we do have an interest group called the Visible Research Software Interest Group. However, this is really if you're interested in driving this change rather than seeking, sort of hands-on support with enabling this change. If this sounds interesting to you and you'd like to advocate for it, then this is a great place for you to go. However, if you just want somebody to kind of help you with the metadata aspects, your local data librarian is actually going to be an expert at doing that. So I thoroughly recommend tapping into it. At least from my knowledge of the Sydney Basin, every library at every university here has a data librarian or something similar. They might be more familiar with research data management, but they can help you, especially with the metadata aspects. And pretty much most of, or all of the unis in Sydney Basin as well, also have hacky hours where you can discuss this stuff with them as well. And yeah, so why bother going to this extra step? Well, the main one is that you're going to get a DOI for your software. And that's going to make it much easier to trace back to your software if it is cited or otherwise mentioned in other scholarly works. And we believe at least that it's going to draw in a larger audience, because by providing that machine actionable metadata, there are services that are being built out there to scrape that metadata and direct more people towards your software outputs. But overall, the thing that I think motivates me most in thinking about why we need to make this this extra step of creating deposits of software is that it creates a more stable base upon which to build more transparent practices. So these are preserved records of your software. They're not, the purpose of them is not so that people can immediately re-execute your code. The purpose is that the record is kept of that code, because it is notoriously easily lost. So a second area of software visibility relates to what we call software citation. So it might be the norm, I think, in this community, that if you're going to publish new software, you're probably going to publish a paper about the software. And in that paper, you may describe the algorithm, the method or the model, or whatever innovation in a journal article. So what I'm going to talk about now is a shift in practice, which is again actually the same practice. We're seeking to make people make their software citable, and to do that, again, it's the same guide, so I'm not going to go through it all again. But there's an additional step. If you are going to make your software citable, then we would also recommend clarifying your preference for citation. So if you have a paper about your software, we would suggest that it's also useful to ask people to directly cite the software as well. So the paper describes the intellectual work, and the software. By citing the software, you're actually referencing the thing that is the intellectual, well, it's a representation of the intellectual work as well. Providing information about how to cite your software. Gosh, I believe it's a recent paper from Cadwallader. They were looking, I think it was in computational biology. The simple act of telling people that how to cite your software increases the likelihood that they're going to cite your software from something like 30% to 60%. So it's not foolproof, but if you are finding that you put software out there and you're not getting a trace of the use of that software, then I think making your software citable and then clarifying how you would like to make it, how you would like to be cited, is a good way to increase the likelihood that you're going to get cited in other papers. So related to that is your own actions. Are you acknowledging the use of others' software in the papers that you write yourself? Perhaps you're putting it in a footnote. Perhaps you're following the relevant guidance from the author guidelines for the journal that you're submitting to. Perhaps you name the software, or perhaps you're actually doing that, as I said before, a citation to a paper. This is super interesting and motivating, but papers about software are actually amongst the most cited articles of all time. You can get the slides afterwards and check out the link. It's a lovely Nature article or Nature opinion piece, I think, from 2014, looking into that. But the potential for software to generate citations for you is quite high if it's impactful software. And the problem is, how are people doing it? We have this lovely study from 2016 from Howison and Bullard, and they looked across various areas of science to look at what were the conventional ways of mentioning software in papers. And pretty high up there, which I guess is a pretty hard number to measure, is that there would be no mention at all. Perhaps there would be a kind of vague hand-wavy mention to some statistical software, say, or they would just simply name the software package, the algorithm, or something like that. They may or may not have provided a version number when they did that, and then there's no further referencing beyond that. They might put a URL inline or in a footnote in the document. They may or may not mention the authors, making it harder to trace back to what it is that they've described, and certainly ensuring that there would be no flow of credit or acknowledgement to the individuals involved in that software. And if not a URL, or even if there is a URL, there'd be no resolution back to the source. So the information that you have doesn't really allow you to trace your way back to the software, except with a heavy bit of Googling and some guesswork and maybe hoping to find it on GitHub if it's recent, or if it's on SourceForge, well, bad luck. So there you go. And following on from that work was a set of citation principles. So there was a very careful look at what the different categories of information were. And they said, okay, well, what is the sort of minimum level of metadata that we need to occur in a citation for it to properly trace back to get that, to make sure that that credit is redirected back to the author of the software. Most critically, what that work was looking at was saying, well, actually what we need to do, the shift in practice, is to cite the software itself. Now, I don't know if this is particularly familiar concept to this crowd, but I have already mentioned it briefly. But the idea is that if there is a paper about the software, it would be in addition to this. And if there's no paper about the software, then it would be to do a formal citation and include it in the references section of a publication. So that first paper there by Katz and Chuhong and Clark et al., that very straightforwardly describes a number of scenarios and how exactly you would end up citing a piece of software, whether it's a commercial piece of software or a piece of software developed under research conditions at any number of levels of complexity or so on. So that is absolutely the source if you want to understand how to do this. And then I think the second step is always to check that the author's preferences are met there too. So if an author has written a paper, and let's be honest, they're doing that because they want to ensure that there's a flow of credit to them for doing that work, then I think it's best to respect the author's preference. But my encouragement to you would be to consider also citing the software, because until we have a groundswell of support for the concept of citing the software directly, it won't basically get taken up as a concept. There are publishers out there who basically support this principle. It's not a huge number, but I think there is growing support for this as a way of working. And it really starts when people just start doing it, basically. So please consider doing it. And to help you do that, apart from the publication that I had there before, we have our own guidance to do that. The link is going to be old in 2 weeks' time. So have a look around on our website. Again, the Visible Research Software Interest Group is there if you have a strategic interest in that. And in fact, there are international activities around this as well. The Scholarly Comms Community Force 11 have a working group that's driving this change. And again, your data librarian, or because this relates to citation practices, a liaison or research librarian at your host institution will happily guide you through citation best practice in this case. Often they come back to us when it gets to the curly end of the question, but they are your first port of call. And so if we follow these instructions, the idea is that we basically undo these variations. It's more likely you end up with a mention in the first place. If they're following the citation guidelines directly, it will be named. It is optionally versioned because it has a persistent identifier, and versioning actually becomes irrelevant, but it's optional. It has a DOI, which what enables that kind of automatic tracing back to the source. It very clearly spells out the contributors if they're available, noting that some software is owned by organizations, and other software, particularly open source software, is pseudo-anonymously developed. It will resolve back to the source, or at least very much a stable record of the work that's been done. So again, the reasons for doing this are pretty much the same. And just as a kind of measure of the kinds of things that this enables, in terms of drawing a larger audience, if you haven't seen CiteAs, go and check it out. That is a website where if you punch in a GitHub URL or the name of a piece of software, or any other kind of scant information for a piece of software, it will try its very best to trace back to a citation for that software. It's a pretty cool tool, basically, and that's the kind of thing that we'll be able to enable with more consistent practices. The final thing for software visibility, and this is just one slide, is code availability. if you're an author of a tool, a software tool that other people are using, you should absolutely love code availability and be shouting it from the rafters. When you share your code, what you're providing is the raw material to trace back to the dependencies you built on. It's not just a record of the work that you've done, it's a recognition that you built it on top of other people's work. So this is in addition to software citation, especially if you were in the camp that thought, but hold on, there's 100 dependencies underneath of my code. How can I possibly fill out my references section with a citation of every dependency? Well, this is the answer. Provide the code. Or encourage the users of your software to share their analysis code, because it's the raw material to trace back to uses of your code. If you want to see examples of your software being used, particularly if it's the kind of software that is a module or a library or something where they're actually writing code to use the code, code availability is definitely your friend. A culture of code sharing can also extend outside of academia. If we have a more open way of working on software, we have more evidence that we can draw upon, more concrete evidence of the use of your software and the way in which it's being used as well. Okay, so on to the second area, making software better shaped, or which is addressing that challenge of enabling broader impact through quality software. We say that shaping software, we shape research software when it anticipates broadest appropriate use, employs best practices for quality software, and where possible, it extends upon existing software rather than recreating it, sorry. So again, this is a shift in practice. I'm going to be honest, I'm going to say it is a bigger shift in practice, and I don't have a nice, easy guide to say how to do better software. It's also a mix of technical and social or socio-technical changes. But some of the stuff that we are doing at the AIDC is really focusing on the scholarly recognition of software as an output of research. And to do that, we've established a raft of early career awards for new software. I'm very happy to see the results from the Venables Awards, which really I have to acknowledge comes from the Die Cook Award, which in many ways triggered this as a way of trying to incentivize the creation of new software. But we've also established awards and sponsored them in ecology, in astronomy, and also in bioinformatics and computational biology. And we're not going to stop there. What we're doing is we're looking at those scholarly fields where there is a pretty high volume of software being produced for others to use, but the scholarly societies or the peers or the seniors, if you like, are not necessarily formally recognizing software as a really valuable contribution to research. And so that's what those research awards are for. We're also looking to promote and celebrate those people who have really decided to throw their energy into doing this activity. At the moment, what we're doing is a monthly series of interviews with what we call researchers who code, or sometimes we call them research software engineers. And what we're compiling over time is a series of case studies that demonstrate the value of researchers who code. What we interview them on is what they love about programming, what they love about their research, and it's also an investigation of what they consider to be best practice within the way that they or ways that they develop their software. And above all, it's a celebration of this really valuable, powerful skill set, the intersection of a high level of research understanding and the practice of a specialist skill in the form of writing software. If you're interested in those interview series, you can subscribe to our newsletter. They do come once a month, and I think you'd have to tolerate a second newsletter every fortnight that sadly doesn't have interviews with researchers who code. But we're building that up over time, and we're really, really happy with the results so far. And for this particular area, we've got more to come. We do go around doing talks and workshops from time to time, and we are aware that we need to start filling out some of our best practice guidance to help people make that shift. But actually, we're very open to ideas. If you have anything, any activity that you think might actually better help in this space. I think there was earlier in the series someone talking about packaging software. That's great to see. That's the kind of thing that that helps bridge that gap, if you like. Okay, so on to the last area of the program, which is about sustaining research software. And this is recognizing the challenge of the lack of support for research software infrastructure. Now, of all the challenges, I think this is actually the hardest of all. We think that we sustain research software when it is complemented by roles which are themselves stable, inclusive, supported, and valued, and when we can identify viable pathways to maintenance. To circle back on that first point there, we really don't see any difference between the provision of a stable piece of research software and a stable role which develops and maintains that software. So in doing so, we're really focusing on the human aspects there, the career progression, the stability of employment, and so on, associated with what we call research software infrastructure. So one of the first sort of actions that we're taking in this space is to try to laser focus on institutional recognition of the value of research software infrastructure. And what we think will help to raise the profile of particularly longer-lived projects in research software is a Eureka Prize for excellence in research software. So we just announced that very recently, and it'll actually be running for the first time next year. We think that this is the kind of thing that makes university administration sit up and pay attention to something that they weren't thinking about before. We also think it's a great way to celebrate the value of research software, of course. But I guess that's our kind of strategic thinking behind doing the action in the first place. We're also trying to help an organization called the Research Software Engineers of Australia and New Zealand grow and mature. If you've never heard of it, you might like to check it out if developing software is a big part of your identity as a researcher. It's really the peak body for researchers of your kind, the class of researchers for whom making software is actually what they do, amongst other things. And they are a solid advocate for career progression for software, as are we at the AIDC. I have something in the wings to promote the now slightly old policy change at Monash Business School, which is formally recognizing career progression. There are a handful of other examples around the country and a handful of examples overseas of institutions that are formally recognizing software as an output and allowing you to put that forward in your case for promotion within the university. But we would like to spread that further, spread it sideways within the organizations and spread it to new organizations as well. So these are future actions for us in planning right now. And then, so that is the whole picture. Take a deep breath. It's a big number of changes. It's a number of actions. But overall, we basically think we need to see, shape, and sustain research software in order to recognize the value of research software. Thanks very much.
Thank you very much. Great. There's a lot of thought to put in what you have been discussing. So thank you very much for this seminar. I will, is there any question from the audience? You're free to raise your hand or unmute.
Yes.
Yeah, Kevin?
Hi, fascinating talk. Thank you, Tom. I have a question about viewing research software as an output. I think, and I'm going to speak in general terms, I'm not pointing fingers at anyone I know, is that a lot of researchers view their main research output as just a paper. And as long as they get their paper published, they don't really care if their software is going to last however long and if it's going to be installable or usable by anyone. So how do you see we might be able to change that? Or yeah.
Yeah, okay. So, I mean, I think there are a few angles that you can tackle with that. I think that perhaps amongst some people in the room, they might recognize the language around impact. And I think that when we take our ideas and we turn them into a usable form, so we take them out of the paper and into a form where we can demonstrate that people are actually using it, or which means that people can use it directly, what we're doing is entering into the world of impact from your work. And so it is at the moment an argued case, but essentially if you go to the effort of producing software, what you're saying is the knowledge that's captured in here is usable and usable. And then if you can show a record of use of that knowledge as well, then you actually have something to augment the record of your work as well. So yes, it is getting a little bit ahead of what the system currently values, and that's why we're doing these extra actions to make it valued. But that's basically the main lens through which I think we can pursue software as a valuable output.
Thank you. Any other question? Yes, Robert.
Tell a joke.
We can see.
But I think that what was mentioned was not just impact in terms of citations. I mean, if people use your software, they're gonna cite your papers. So that Rob Honeyman actually is a good example of that. So that if you know, the currency is not just whether you publish, but whether you get cited a lot. And you will probably get cited a hell of a lot more if people use your software than if they don't.
I think that's right. Yeah, basically. So, and as I said before, you know, the simple act of of both making your software citable and then asking people to cite it is going to increase the likelihood that it's cited in the first place. So there are a lot of people outside of statistics who might potentially be using your software who wouldn't necessarily think of citing it, wouldn't necessarily understand that what you were doing was a scholarly piece of work. And it's a bit of the danger of open source software is that it's a bit of a blurry line between what the credit or value is behind that. So the simple act of clarifying that is going to direct more people there, for sure. And yes, it is. It's the most, it's really essentially the easiest way to express it is that methods are the most cited papers. So there are some, you know, wet lab methods and so on that are very highly cited, but software is really solidly in the top 100 list of most cited papers of all time.
So we have a question from Judy online. So could a collection of analysis scripts be considered a research software? Researchers who code would commonly write code to use with existing packages or toolboxes.
Yeah. In my conception of research software, I see essentially three forms of software that I classify based on the purpose for which it gets written. So and you could think of these as arranged in a stack as well. At the top of the stack would be analysis code and other kinds of typically one-shot code, but sometimes used more than once within a project. And if I think that's actually what would fall under the definition that you gave there. But it's more than that to me as well. It's more than analysis code. It's also the code used for data handling and so on. And what it documents is a kind of record of the work that's done. The next layer on the stack would be prototype tools, which is when you move outside of the project and start thinking about capturing your software or demonstrating your idea in a way that other people can use. It's a prototype because it's new, not because it's to be thrown away, or you could call it a proof of concept. And the third kind of software moving down the stack is the kind of software that captures more commonly accepted ideas, methods, and models. It might be software written based on what you read in a textbook, or it might simply be software that's moved on to have a reasonably large user base of people, justifying the ongoing maintenance of that software. So absolutely, analysis script is at the very top of that stack, and it's a really important part of the overall spectrum.
Thank you. Any other question? Yes, Robert, go ahead. You're muted.
I was just assuming that you could all lip read, but when we look at papers, we say, you can publish in JASA, you can publish in Biometrica, you can publish in much lesser journals. And we say, is it new? Is it interesting? Is it correct? And there's various grades on that. So that if you were to do the same thing for software, rather than saying software is good, and you had some 3 or 4 other dimensions compared, comparable to what I have now, how would you rank the various software contributions from really the best to not so good? So in other research, you would say, is it really, really novel, or just a little bit novel, or just, and is it, to what degree is it correct and rigorous, and to what degree are people interested in it? How would you rank software on relatively similar scales?
Well, I mean, there's multiple problems going on there at once. I think when you're talking about the quality of the software, we're seeing a recognition that there needs to be more than one solution out there. So, for instance, the Europeans are really interested in handling that at volume at the moment, and they have a working group at the moment under one of the EOSC task forces looking at to what degree can we mechanize or automate the assessment of the quality and robustness of the software, because how are we going to do this for potentially thousands of bits of software coming through that pipeline at once? The second approach is more scholarly. So there is a Journal of Open Source Software, for instance, and other journals that accept software as their main purpose. So they exist to essentially create articles that notify people of the existence of software. Which incidentally, you know, I constantly hear Dan Katz say he created that with his peers with the hope that it would disappear, that people would just start citing the software directly. But what's happened in that journal is a community sort of sprung up where they've looked at peer review practices and sort of minimum criteria that have to be fulfilled that are another way of measuring the quality of the software. And when people do it that way, I guess citation becomes a proxy for the relative novelty or usefulness of the software itself. The third one is downloads. I'm not a huge fan of downloads. It's a very difficult measure to base the usefulness of software on. Basically, there's always been this sort of problem of scale with software. Software can be really big and complex and have multiple facets, or it can have a very singular purpose, and this distorts downloads as a metric of the usefulness or quality of the software as well. But generally speaking, what's most commonly put forward is some notion of peer review as well. If not through journals, then through some kind of quality checking before it goes into a repository or something similar. I hope that covers it.
Because that's just the start of it. Because in journals, when we put articles in journals, we know they're going to be peer reviewed. The question is, what are the criteria that the peer reviewer is going to use? So my question wasn't about, you know,
right.
If you look at citations, you know, you sort of say, well, am I going to accept this for a journal? Well, let's look at the citations, but you can't do that because you're not going to wait 6 years for an article in archive to be cited. Maybe you are, and then say, now we'll publish it when it's too late to actually publish it. So the question is, what are the criteria that we are going to use to say this piece of software or this piece of computing is superior to that in the good software journals? The other question I was going to link to that, in computer science, how do people view software and the creation of software in computer science?
Yeah, can I start with the second one first?
Yeah.
I was somewhat surprised. I assumed, sorry, I mean, I only have undergraduate computer science degree, but I had assumed that producing software would be relatively highly valued in that community. It's not. It's still very important to generate papers. It's sort of very variously distributed how much a particular department supports or endorses the activity of contributing to software. To go back to your first point, there's still the problem of splitting between imposing metrics on the shape of the software and the degree to which it's been engineered well, versus a judgment or an endorsement of the originality of the idea within it. And then third, actually, I think comparing similar software is kind of a task within that may or may not be relevant. So if the idea is genuinely new, then it will be the only piece of software that does that. And it's not really a comparison between two bits of software producing the same or attempting to tackle the same problem.
Well, it could be. They could tackle the same problem, but one does it so much better. I mean, for example, if Clara writes a theorem and somebody else writes a theorem, and I won't say who's going to be better at that. No, but somebody could have a much nicer proof and much weaker conditions. I mean, if you look at Hadley Wickham, then he's produced some really nice stuff, right? And you would say that who is sneaking behind you, actually?
This is my daughter, Neve, who is now disappearing. If you give me just 10 seconds.
No, bring her up. Bring her up.
I don't want to embarrass her, but I will just check that she's okay. So just please give me a second.
Sure.
In the meantime, I would like to share that next week, the SSA New South Wales branch has an event for young statisticians, in particular interested in a possible career in industry. And I put the link in the chat for those of you who may be interested. It will be in person at the University of Sydney, and a buffet will be provided as well. Sorry, Tom, go ahead.
Yeah, and who said that this talk wasn't family friendly?
I didn't.
Look, this is, I think I actually started the conversation by, you want to get me a knife?
Oh, no, don't do that. Don't do that. Look, all is forgiven. Just don't.
It's a Kiwi.
Put that knife down.
So, as I said at the start, this is actually what I really enjoy about traveling across different research areas, is that the answers to these questions actually varies by community. So, you know, what is leaping out to me here is the importance of, in some cases at least, of, I guess, interrogating the robustness of the algorithm. And perhaps that's a conversation that is better taken within the traditional scholarly domain. And what the software variant does there is it's a functional, practical demonstration of the software too. So you can interrogate that algorithm from other perspectives. You can apply it and actually see what happens in an empirical sense. But that wouldn't be the case in some other domains where perhaps what you're doing is innovating a way in which data is processed or visualized, and you're just basically looking at the output of the software and deciding whether it's useful or not. You're not necessarily interrogating the internals of it. I mean, the other dimension that's really complex about this is that I don't think we should necessarily be overly concerned with the robustness of the software when we're just demonstrating an idea. That's something to happen over iterations after the initial idea gets out there. So if you can prove that an idea is useful, then the second phase would be to look at the robustness of the software as well.
Yeah, but there's a lot of contradiction here, some contradiction, because if it's not robust and you put it out, you will get, that will cause more harm than good, because people will use it, and rather than say focus on the idea, they'll focus on the fact that it doesn't work, right? You know, so, you know, you sort of read something and then you get the software and you just say, it doesn't work, I'm not going to use this, rather than say, good idea, but terrible implementation. But if it's terrible implementation, then is it good software? So well, that, you know, so you've got to be, it's like saying, look, this is a great idea, the proof is all wrong, but if somebody really good spends time on the idea, then so what do we do? You know, the proof's all wrong, do we publish it and somebody else will improve the proof, or what's going to happen? So you've got to sort of be a little bit more objective about this.
Well, yeah, I think that's true in the abstract. I think in
it's true in the non-abstract as well.
Well, no, I mean, I think practically, when we look at how research happens in different domains, there is a certain level of imprecision that it is accepted in some areas of research, and identified as well.
But if you talk about quality software, presumably that means it's robust. There
is this concept amongst best practice in software that it should be fit for purpose. And the danger of over-engineering a piece of software is that you put too much effort into making it robust without having demonstrated the value of the idea in the first place. Well, there is a danger, of course, in over-engineering that you make it very slow, right? Because you check each step. But also that you're repeating someone else's work, or that the idea is otherwise not original. I like the talk, but there is this gap. If we were to, if we were to judge something the way we judge research articles in terms of just mathematics and methodology, we've got certain criteria we've developed now, and we've got journals of various rankings. The other thing that I'm a little bit worried about is the fact that if computer science doesn't take this seriously, I want to know the reason why, because they have all, and of course, Dennis Ritchie and C and etc. They were, and Linux and that, they were big deals. So why don't they take it seriously? Or maybe they do. Look, it doesn't mean that the whole of computer, I wouldn't want to paint it with a broad brush. I have to jump back a little bit and say, in terms of actually making this concrete, the person to talk to is Rob Heineman, because he's actually had to tackle this with his policy. He's had to think about how it is that they make judgments about the relative ranking of the software. But I can't necessarily answer it for statistics. I'm not really in a position to do that. It's actually something that the community itself has to determine. Yeah, but my question was broader than that. It was just, how do we distinguish between various qualities of the software? Yeah, and again, I can give you heuristics about how we make those judgments, but I can't necessarily give you a solid list of what. Okay, so watch out for my talk next week about statistical software. Just kidding, Clara. All right, so I've taken enough airtime, but no, thank you. They're great. They're great and very reasonable questions. Yeah.
So yeah, it went almost philosophical. So I would just conclude, since Mitchell wrote some time ago, but I would just ask his question, who says, what might citation look like for contributions made into existing software packages? For example, the implementation of your original algorithms into an existing project.
That is such a fabulous question, because I think, if you were looking at what we saw as better shaped software, it is to drive people into contributing to existing projects over splitting too often, which is particular concern in fields like bioinformatics, where a lot of people reinvent the same methods over again. Well, not reinvent the method, they re-implement the method over and over again, rather than contribute to existing software. I don't precisely know the answer. If it were captured fully in a single pull request, or within a specific release, if you wanted to make a precise reference to it, there are a couple of mechanisms. This is a very wonky question, I just have to say. If you needed to make a specific citation of a pull request to a software project that was developed openly, one mechanism that you could use is the software heritage identifiers. So software heritage is actually an archive of all open source software, just about. Well, actually, don't quote me on that. I doubt it's all. But they do scrape pretty much all of GitHub and a large number of package managers and make a preservation copy of software. And then what they provide with that service is a very high resolution identifier system that allows you to reference spans of code or the whole software project, all the way down to modules and components, but also specific commits as well. So if you wanted to make a precise reference to the effort that you had put into a larger software project, that is one mechanism that you could use to extract an identifier that would be definitely referring just to the code that you had produced. And then I don't know if that scenario is actually covered in the guide that I linked to from Katz and Chu Hong and all. If it isn't, I'm going to raise it with Dan and see what he thinks as well, because it's a completely valid point. We have the same problem with the Eureka Prize, by the way. I'm trying to solve how can we have people put in an application for the Eureka Prize where it's not that they created the whole thing, it's that they made these contributions over years. How can they refer to a portion of software as their software? It's a really thorny problem. Yeah.
Well, thank you. And thank you very much. I think we are over time. So I would like to thank you again, Tom, to join us tonight. Thank all of you for the great discussion. It's been one of the most lively discussion we had. I would just like to remind the event for Young Statistician next week on the 29th. Follow the link, and our next seminar will be on the 26th of October. Thank you again, all of you. Have a great night, and thank you again.